In this video, we're going to simplify square roots a little bit more. And these first four problems here, well, actually two problems, I should say, are not very difficult. We're not adding a whole lot to what we have already done. So what we have to do is just simplify the square root of 27 here in this first one. We'll start with number one. And then we are going to take whatever we get, and then whatever numbers are outside, we're going to multiply those together. Watch. So 3 root 27. We're going to just write that as 3 root 9 times 3, because 9 times 3 is 27, and then 9 would be our perfect square, right? So just think about it this. Just think this much as your problem right now, okay? That's all we're thinking about. So we're going to rewrite that as 3 times root 9 times root 3, excuse me. And then we're going to go 3 times, and what is root 9? That is 3. So 3 times 3 times root 3 equals 9 root 3. And that is our final answer. Why don't you try number 2 on your own? All right, so what we want to do first is figure out what perfect square goes into 18, because we know that 18 is not a perfect square. Want to look at our perfect square chart, or just memorize them, know them. 3 times 9, root 9 times 2, okay? So it's very similar to the last one, it's just that it's 9 times 2 now. So equals 3 times root 9 times root 2 equals 3 times 3 times root 2 equals 9 root 2. And that is our final answer. All right, how did you do? Number 3, we have a negative square root to, or negative root to simplify. So if it's negative, if it starts negative, we're gonna end negative. So we just don't want to forget the negative sign. So really the square root of 8 is what we're gonna need to simplify here. So negative 2 times the square root of what? 4 times 2. Why 4? Because 4 is the perfect square that goes into 8. And it's easy to take the square root of 4. So square root of 4 is 2 equals negative 2 times 2 is a negative 4 root 2. That's our answer. All right, number 4, okay. Now this is an interesting one, right? Because we have the square root of a negative number in here. I'm gonna just tell you right away, this is impossible. We cannot take the square root of a negative number. Why is that? Well, think about it. If I have two numbers, if I multiply two numbers together, even if I multiply two negative numbers together, like, I don't know, negative 3 times negative 3. Well, I can only get a positive number if I do that. So remember that the square root is calculating whatever you multiplied by itself to get that number. So the square root of a negative number is impossible. You cannot find that. It doesn't exist. Because look, negative 3 times negative 3 is always a positive, right? Negative times a negative is always a positive. So if you do a negative times a positive, you can get a negative. However, you're not multiplying something by itself to get it, right? Because it's a negative times a positive. That's not the same thing by itself. So I'm just gonna stop talking and say that this is not possible. Okay, all right, so the next few problems deal with variables. And before you get all nervous, I'm just gonna say this is actually easier than you think with variables. Variables are actually easier to take the square root of than numbers. And you'll see why in just a second. But what we're going to do is we're going to split things into factors, just like we always did under the square root. So the square root of 24x would be, well, perfect square goes into 24. Remember, that's 4. That's our 4 times 6, right? And then we've got the x. So square root of 4 times 6 times x. And then we're going to split and use the product property of square roots. And I'm just going to write this as square root of 6x because I know that I can't take the square root of 6 or x. But here's what we do. When we have a variable in there, first of all, we can't take the square root of x, so the simplified version of it would just be the square root of x, okay? Just like we can't take the square root of 3 and get an exact answer, well, we can't really take the square root of x. We can't simplify that any further. So we're gonna go square root of 4, which is 2, and then times the square root of 6x. We can't simplify the square root of 6 any further either. So whatever we cannot simplify stays under the square root symbol, okay? Stays under the radical. And then whatever we can take the square root of goes on the outside. Number 6. This is a little different, but very much the same. We have to take the square root of 24, which is it a perfect square? No. What goes into it that is a perfect square? Well, we already determined that. It's 4 times 6, okay? So we'll just do our 4 times 6 times our x squared. Now, the only difference in this problem is we have an x squared now, right? So let's just go about the problem the same way, and then I'll show you what to do with the x squared at the end. Okay, so we got 6, except what I'm going to do now is I'm going to split this up a little more, and I'm going to go square root of 6 times the square root of x squared, and that is totally fine. As long as they're being multiplied in here, you can do this. Now, the square root of 4 is 2. The square root of 6 we cannot simplify, so we'll just leave as is. But this can be simplified. What is a square root of x squared? Well, remember, folks, whenever you have a radical, whenever you have a square root sign and a squared, they cancel each other out. So what we do is we really just cancel these out, and then you will get just x. But the rule is the following. Whatever exponent you have under the radical, okay, under this radical, in this case, because it's a square root, you're going to divide it by 2. And then you're going to write it without the square root. Okay, so what's 2 divided by 2? 1. So we don't need to write the 1. But there it is. And I'm going to write that x there. I'm going to write everything under the radical last, just like that. Okay? All right, a couple more. Number 7. All right, so why don't you try this on your own? Now, we got 32. Well, is that a perfect square? Nope. What can we multiply by itself to get 32? We can't, nothing. So we're gonna have to find whatever perfect square goes into 32. So that would be 16. 16 times what? 2 times n to the 3rd power. So we take the square root of 16, that's easy peasy. And then we got the square root of 2. And then we've got the square root of n to the 3rd power. And I'll show you what to do there, but we're not going to have to really worry so much about that, but I'll show you. This becomes 4, right? Then we still have root 2. That can't be simplified. Here's what you're going to do here. Whenever you have an odd power, okay, so like 3, 5, 7, 9, etc., what you're going to do is you're going to break it into the even power, the even number, whatever it is, okay, because we're just going to we're going to first break this, sorry, I'm not explaining this well, n squared times n. So we're going to break it into whatever even power we can find, so whatever is 1 less than this one, and then we're going to break it into that, okay? Why are we doing this? Well, I'll show you in just a second. So why? Because we can write it like this. Now we can do this one, but this one's just going to stay the same, right? This is the same thing as the square root of n to the 3rd power. Okay, so let's just see how much you can section this off, how much you can split this up. Look how much I'm splitting it up. But you have to be able to see that you can do that. All right. So remember I said, divide this by 2, and then the squared goes away. And then you've got this, really. So you got 4 times, and then that becomes root 2. Then that be, well, that, yeah. And then you've got this, okay? So now I just go 4 times n. I'm going to write all my variables on the outside, and then whatever's on the in the root next, okay? So 4n times the square root of 2n, okay? Because it's the same. I'm just multiplying the square root of 2 times the square root of n. So that's my answer, okay? All right, took up a lot of space on that one. Okay, this one's a little more similar to some of the first ones we did. Go for it. All right, how did you do? Well, the square root of 16 we know how to do. That's pretty easy. And then the square root of a will stay the same, won't simplify. And we just have 4 root a. That's our answer for number 8. Number 9, 150 n to the 4th power. Okay. So 150, what on earth? That's a big number. Well, is it a perfect square? Look at your chart. You'll see that it is not. So what perfect square goes into it? Well, that's 25. So I'm going to go 25 times 6 times n to the 4th power. That's how I'm going to write that. Now, I can take the square root of 25, no problem. We got the square root of 6, that'll stay as is. And then we've got the square root of n to the 4th power. Remember what I said about exponents. We need there to be an even exponent. Why? Because we're going to take it and divide it by 2. We always take that and divide it by 2, whatever exponent we have. If it's odd, though, we have to section it off like we did up here first. So like I did right up here, okay? If it's odd, we need to do this, okay? So that we have an even one right here, right? Because we're going to have to divide it by 2, and only even numbers can be divided by 2, right? Okay, so let's divide that thing by 2. What do we get when we divide it by 2? 4 divided by 2, it's 2. So we got 5 times root 6 times n to the 2nd power. Okay, so I'm going to write everything that does not have a square root over it first, like I said. So that would be 5n squared, and then the square root, and we are done.